Hello students, welcome to this lecture on starters of DC machines. At the end of this video, you will be able to understand what is a back EMF and how does the back EMF influences the armature current and what is a starter and the different types of starter. Before getting into all these points, let us understand what is Faraday's electromagnetic law of induction. You know, when there is a relative motion between a conductor and a magnetic field, a voltage is induced. This concept of electromagnetic law of induction is responsible for producing the back EMF in a DC machine. Faraday concluded whenever there is a relative motion between a conductor and a magnetic field, the flux linkage with the coil changes, and this change in the flux induces a voltage across the coil. For example, let us take a circuit diagram of a DC shunt motor. A DC shunt motor has an armature and a field winding connected in parallel with it. The resistance of the armature is represented by Ra, the armature current is represented by Ia, and the shunt field winding current is represented by ISH and its resistance as RSH. V is the terminal voltage that is applied to the motor. So the field is going to produce the flux, the armature conductors are rotating, since the rotating armature conductors are cut by the flux, there is a relative change in the magnetic flux. So according to electromagnetic law of induction, whenever there is a rate of change of flux, an EMF is induced. And this EMF, we call it as the back EMF in a DC machine. The expression for back EMF EB is given by phi ZNP by 60A, where phi is the flux produced by the field winding, Z is the number of conductors present in the armature winding, N is the speed at which the armature is rotating, P is the number of poles in the armature, and A is the number of parallel paths in the armature. So now we know the expression for the back EMF. EB is equal to phi ZNP by 60A. So the back EMF is influenced by the flux produced in the DC machine or the field winding. It is influenced by the number of conductors present in the armature winding. It is also influenced by the speed of the armature and the number of poles present in the armature along with the number of parallel paths of the armature winding. So a quick review of what is a back EMF. Back EMF is nothing but an EMF induced in the armature of the motor when there is a relative motion between the magnetic field produced by the shunt field winding and the rotating armature conductors. So how does this back EMF influence the armature current of a DC machine at the time of starting? We know from the previous circuit diagram the terminal voltage is nothing but the sum of the back EMF and the resistance drop or the IaRa drop in the armature. So terminal voltage V is given by EB plus IaRa. Since now we are concerned with the equation for the armature current, let us rearrange this equation. Let us bring the armature or the back EMF into the left hand side. So the equation becomes V minus EP equal to IaRa. From this, the expression for armature current is given by V minus EB by Ra. At the time of starting, the armature conductors will not be rotating or they will be at rest. So there will not be any relative motion between the magnetic flux and the armature conductors. So the back EMF will be equal to 0. So at the time of starting, EB is equal to 0. Substituting this value of EB, which is equal to 0, in the armature current equation, we get IA equal to V by RA. Now let us take an example of a DC shunt motor which is running at 220 volts and has an armature resistance of 2 ohms and its rated armature current is 12 amperes. This is given by the manufacturer. Substituting these values in the equation for armature current, we get IA equal to 220 by 2, which is equal to 110 amperes. But you can see the maximum armature current that can be taken by the motor as given by the manufacturer is only 12 amps. But what is the current at the time of starting? It is 110 amps. So which will obviously damage the armature winding of the motor. So how to reduce this current of 110 amps to a permissible value? That is done with the help of a starter. So how to limit the starting current? Starting current can be limited with the help of a starter. So coming to what is a starter? Starter is nothing but a resistance in series with the armature. What is the property of a resistance? It is going to oppose the flow of current. In the previous slide we have seen at the time of starting 110 amps of current is going to flow into the armature. So by some means we need to reduce the amount of current that is flowing into the armature. The possible way is using resistance in series with the armature. So starter is nothing but resistance connected in series with the armature. The resistance are connected at the time of starting and are gradually cut out as the motor picks up speed. What happens as the motor picks up speed? The relative motion between the magnetic field and the armature conductor gradually increases and the back EMF builds up. Once the back EMF builds up, the armature current is gradually reduced. That is why we call the DC shunt motor as a self-regulating machine. So to sum up, the starting current is limited with the help of a starter. Starter is nothing but resistance in series with the armature. It comes into the picture at the time of starting and is gradually cut out as the motor picks up speed. There are different types of starter available. They are 3-point starter, 4-point starter and 2-point starter. These starters are decided based on the type of motor which we are going to use. For example, the 3-point starter and 4-point starter is used for a DC shunt motor and the 2-point starter is used for a DC series motor. In the next lectures, we see in detail what is the construction of these starters, how to operate these starters, and what are the different protection schemes available for these starters. Thank you.